So here we are going to start something new. Okay, I know in the third edition of the book, this was section 2.4. In the new edition, I think it's the same. I'm not 100% sure. But either way, we're going to learn a new topic today called functions. It's actually one of the most important topics you will see in this course. And functions are something that, mathematicians study constantly. In the other sciences, they come up. If you go into other math classes like pre-calc or even calculus, you will be studying functions. They are very important. I mean, unfortunately, also, they're not so easy, but again, I'm hoping that I'll be able to explain them well. All right, so here, what I want to do is I want to present the definition, what a function is. I also want to show you that functions can come about from what are called relations, correspondence mappings, and you can actually use equations and graphs to define functions. We actually have seen them already in the course. I didn't say it was a function, but we actually have seen them already. And then there's something you might have seen before called the vertical line test. That will come up later. Okay. All right, so this is what we're going to see. The definition is very abstract. So if you don't understand it at first, don't, panic or anything. But remember this definition. I'm not sure if I gave this before, but you will see the word set. And a set is really just a fancy word for a collection. So a set, by definition, is a collection of something. A collection of objects, for instance. You could have a set of numbers. You could have a set of, names, letters, anything really. A set is just a collection of objects. The book goes a lot more into set theory than I would want it to. Not to say you can't handle it, but I just think it goes more into it than I think it should. We do use curly braces for sets. And really the way we're going to write out what a set is, we're just going to list all the elements. We don't list an element more than once though, but we do list the elements. I think that's actually what they call the roster method. Like the roster for a class, you list each person in the class, the roster method. And again, we separate, when we list the elements, we separate it by a comma, each element that is. But again, there's no repetition in a set. You can only list things once. Okay. So now, what exactly is a function? Well, here we have a set called capital X. People usually use capital letters to denote sets. Here's another set, capital Y. A function, little f, from a set capital X to a set capital Y. It's a rule that assigns to each element, little x of x, exactly one element, little y of y. So a function is a rule that's taking each element from the first set, capital X, and it's assigning each little x, each element here, to exactly one element, little y, in the second set. So little x and little y, these are just, elements in the set at capital X and capital Y respectively. And the function is taking each element from the first set and assigning it to one element, exactly one element from the second set. And that's what a function does. You can almost think of a function as like a machine. The machine, it takes input, right? And a machine also gives you back output. Okay? For each input into the machine, you get only one output. That's really what a function is. I know it's very strange. You're probably thinking, what the heck is he talking about? But again, bear with me, okay? It will make sense after a few examples. It will take some time. Okay, but again, you can think of a function that way. It's like a machine where x represents your input, goes into the function. The function is a rule. You know, it's a machine that is. And for each x that goes in, only one element comes out, called little y. And little y denotes that element that comes out. Okay, one goes, for each one that goes in, only one comes out. Here's some other terminology with this. With a function, the first set, right? That's where all the input comes from, all the things going into the function. That's what we call the domain of the function. So the domain is everything that is the set of everything that can go into the function, everything you can put into the machine. Now, everything that comes out of the function in the set capital Y, in other words, all the elements of the second set that are assigned to elements from the first set, you know, all the outputs, in other words, all the things that come out of the machine, out of the function that is, that's the range of the function. What I'm actually using here is what we call a correspondence diagram. It makes it a little bit more visual. And again, capital X here and capital Y, the two sets, they can theoretically be anything. For us, though, we're going to focus on real numbers. So capital X and capital Y, they're just going to be collections of real numbers. All right. I hope everyone is with me so far. Again, you know, let's see some examples. So let's suppose first, let's consider this example. The first set, capital X, right? Let's say it's only the numbers 1, 2, 3, and 4. Capital Y is the set 2, 4, 6, and 8. We're going to make a function, and it's really going to be just like the definition from before. We're using arrows. So 1 here, the function's going to take 1 and it's going to assign it to 2. So the function, the rule, is taking 1 and assigning it to 2. Right? 1 only goes to one element. Same thing with 2 over here. 2 only goes to 4. Doesn't go anywhere else but to 4. 3 only goes to 6. 4 here only goes to 8. Okay, does someone have a question?
Yeah, how do you know which input goes to which output? Like, how do you know which one is specific?
That's what the arrows here are telling us, right? 1 is going to 2 over here. You know, it's not like 1 is going to 4 or 1 is going to 6. Here, you would just follow the arrow.
Oh, I meant like in the instruction, like up above where it says assume X and Y. Like if we didn't have that, if we had to do it on our own, like how do you know how to do that?
How to get X and Y?
Like if you had the circles were empty and there weren't any lines, like how do you know if you have just X
Oh,
and
that
Y?
will be given to you.
Oh,
You'll be given that somehow. Okay? You'll be given that somehow. You're welcome. Good question, though. Yeah, but capital X and capital Y, that will be given to you somehow. Okay? Well, that or the function. You'll be given enough information to come up with this stuff. But this is a function that we can make, though. But again, notice the main point is that each input is only going to one output. Right? You're not having, for instance, 2 over here going to 4. And you don't have 2, you don't have another arrow taking 2 to 6, okay? That's why it's a function. And that's not the only function we can make, in fact. Here's another function we can make. Here, I have 1, follow the arrow, walk along the arrow, right, 2, boom, 8. You have 1 going to 8. We have 2 Now 2 is going to 2. 3 is now going to 4. 4 is now going to 6. So there's different ways you can define a function, right? This is a different rule than this one. I mean, the domain and the range are the same, right? The domain is 1, 2, 3, and 4. The range in this case is all of y. And it's the same thing over here. But now notice that we have a different function because it's acting differently. But again, each element from the first set is only going to one other element. You know, 1 here is only going to 8. 2 is only going to 2. 3 is only going to 4. 4 is only going to 6 and nowhere else. Right? So each element from the first set is mapped to only one element from the second set. Okay. Any questions again? I mean, sorry, any questions at all? That's what I meant to say. Okay. Well, this is not a function here. Now, why is that? Well, notice that 1, I mean, I didn't say what 2, 3, and 4 are going to do, but really, we can see right away this is not a function because 1 is going to 2, but 1 is also going to 8. You have something from the first set that's mapped to more than one element from the second set. Well, that's not a function. You can't have that. Okay, you can't have that. You know, because then you're going to wonder, well, which one are we going to use? Do we use 2? Do we use 8 for our output? You know, what do we do? I mean, that's really what makes functions so useful is that each input gives you only one output. I mean, so again, correspondence diagrams you can use to make functions. Functions actually appear almost everywhere. So this is one example. Again, if we want to use a function, but if we put 1 into our function, well, which output are we going to deal with, 2 or 8? So that's why a function can only, by definition, it can only have, excuse me, for each input, one output.